this is, we're doing these. All right, so we're comparing, and let me just make this a little bigger. Can I? Yeah, I can. So number one, box plot below compare the test scores of 2 math classes, right? So, and we're looking for which one correctly compares the data. So you need to go one by one. The range is the same for both classes. Well, the range for this class is about, it's not even a 20, it's like 19. So 19 minus 6 is 13. And the range for this one, and then it's 20 minus what? This is 8? That's 12. So that's not true. They're not the same. Well, they're not the same. Okay. The interquartile range is the same for this class. So do you think this box, which is the interquartile range, right? This one and this one box is the same size? No, they're not. So if you did Q3, right? Q3 minus Q1, do you think you're going to get the same answer? No, so that's also garbage. Now, and then C says the median for class B, here's the median, is bigger than the median for class A. That's true, so definitely, you don't have to go for D. C is the right answer. Number 2. Now, the idea here is also to try to do this without a calculator, just using, I mean, we're trying to look at the graphs and see if we can compare them, right? I mean, you can use a calculator, but I'll try as best as I can not to. So letter A says that the distribution, the shape, this is symmetric, right? You can tell this symmetric. Is this symmetric? So it says that A and B are symmetric. A and B are not symmetric. So this is out. B, the mean growth of flower B is greater than the mean growth of flower A. So the mean, the average, do you think the average here is greater than the average here? I think so, but think about your test scores. You got a 3, a 4, 2 5s, a bunch of 6s, a bunch of 7s, a bunch of 8s, and a bunch of 9. Do you think this test score, the average here, would be greater than here? I think so, right? So again, this, by looking, I can tell that this is, because the grades are higher here, right, than this person. So if this, I mean, I know it says flower and flower, but imagine this as your grades. Who do you think has the better average, this person or that person? So far, I would vote for this one. The median for B is smaller than the median for A. So again, you can cross it out, cross one out, cross one out, cross one out, right? And keep crossing. This one is easy. So the median for A is between 5 and 6. So you would have 5 and 6. So the median is 5.5. What about B? Where do you think the median is going to be? So 3 and 9, cross 1 from each side, right? And I should be wearing my glasses. So again, the median for flower B is 7. And this is 5.5. And this says this is smaller than 5.5. It's not true, so that's garbage. The range of flower B is greater than the range of flower A. The range here is 9 minus 3, so the range here is 6. What is the range here? 9 minus 2? The range is 7. So is B bigger than A? No, it's not. It's A is bigger than B. So the answer to this one is B. Number 3 says which one, the dot plots, which statement about the donations collected by Alicia appears to be true. Okay, so the median donation collected by Alicia is greater than the median by Martha. So Alicia is bigger than Martha, the median. So again, just you can quickly do this. One from each side. So the median is going to be 19 over here. And what is the median going to be here? I don't know, cross 1 from each side, 3, 1, this, 1, this, 1, this, 1, this. And the median is the same, so they're not different, okay? So the median are the same, so that's not true. B, the data for Alicia's donations and the data for Marcia are approximately symmetrical. Is this symmetrical? Does this look symmetrical to you? If I cut this in half, does this side look like the other side? I guess. But is this the bottom one symmetrical? No, it's more like skewed left, right? So this is not true. This is not true. The data for Alicia's donations and the data from Martin are skewed to the right. No, they're not. They're skewed to the left. This one is skewed to the left, right? It's going that way, so that's garbage. And the range of donations collected by Martha is greater. So what's the range here? 21 minus 15, so the range is 6. What's the range here? 22 minus 15, so the range is 7. So the range of Martha is greater than the range of, what do you call it, Alicia? So that's true, right? This is 22 minus 15, which is 7, and this is 22 minus 15, 21 minus 15, which is 6. So the range, Martha, so this one is the one that's true. 4, so here you have a dot plot. The minimum test score from class B, this is the minimum, is greater than the test score from class A. No, they're not. They're the same. The median test score from class A, here's the median, is greater than the median class for class B. Is this guy over here bigger than this guy? No. The interquartile range, so this Q3 over here, this is Q1, this is Q3, this is Q1, of class A is smaller than class B. So obviously you can tell, look at the size of this box. Is this box smaller than this box? That's true, right? And that's your interquartile range, right? The size of that box there. So if you did Q3 minus Q1 and you do Q3 minus Q1, don't you think the answer for A would be smaller than the answer for B? So that's 4 is C. 5. Here's again another dark spot. Which one is not true? Which one is false? So you're looking for false. Which one is false? So the median novels are both, for both classes, the same. Is the median? Is this median and this median the same? No, they're not the same. So is that true? This is not true, right? Not true. So we can even stop. It's this one. Okay, they're not true. That's not the same. So I'm looking for the one that's not true. So we're done. We can move on. 6. Which statement is true? So now we're looking for true, right? The other one was not true, which is different. This one we're looking for, which is the true one. The boys' height have a larger spread than the girls' height. Boys' height. So look at this spread over here. The boys' height, the spread. Look at this from here to here. Is that bigger than from here to here? It looks so. So A is true. B, at least one boy and one girl is 72 inches tall. Well, there's definitely one boy who's 72. Is there one girl who's 72, which is about here? No, so that's not true. The boys' height have a center height that is 10 inches larger. So what's the boys' the medium here? The center is 60. What is the girl's medium? It's 55. Is that 10 more or just 5 more? It's 5 more, so that's not true. The whiskers on the dot plot, the girl's height, are more varied in length than the whiskers on the boys or the box plot of the boys. No, that's not true either. So this one is true, right? So if you look at this one, which one is longer? The boys are longer, right? So the boys have a larger spread than the girls. 7. Which statement is not supported in by the information in the box plot? So again, what information is not supported? The box plot for Mr. Watts' students has a larger interquartile range than the box plot. So is this bigger than this? Yes, so that's okay. So again, not, right? So that's good. The whiskers on the box plot of Mr. Watts' students are more varied in length than the whiskers on the box plot for Mrs. Andre's student. So you can tell this whiskers over here. In a second. Yeah, they're more varied in length. Yeah, they're bigger. You know, right? It starts from 0 to 9. This is, I don't know if that's true. It's not supported. I'd say that's true. 7. At least one student in Mr. Watts' At least one student in Mr. Watt's class sold 10 raffle tickets. Well, actually, I don't know that. How can you look at this, Mr. Watt's class, and see how many people sold how many raffle tickets? We just don't know. Okay, and again, sis, Mr. Watt's class, some person sold 10. Do you see? Look at Mr. Watt's class. Do you see anybody here? No, right? So there's nobody at 10. Mr. Watt's class only goes up to 9. So this one is the one that is not true. So that one is not supported. 8. The box plot shows a science test score. So 2 classes took a science test, class A, class B. The median, so again, not true. We want the one that's false, right? So not true means false. The median test score for class A and B are equal. Is this median and this median the same? That's okay. Neither data sets are symmetric. Is this, if you cut this in half, is this the same as this side? No. If you cut this in half, is this the same as this side? So this is saying class A is not symmetric, class B is not symmetric. So that's true. The maximum test score for class B, what's the maximum test score? Is 90. What's the maximum test score for class A? Was about 80. Is 90 bigger than 80? Yes, so that's true. So the only one that it can be is D. So they have the same spread. Is it true that they have the same spread? No, look. This, compare that to this one. Class A, the spread is much bigger. This whole line here is much bigger than this. Okay. Number 10. So the dot plots below show scores on the math test in Class A and Class B. How many points greater was the mean scored in Class A by the... So this one, you're going to have to find the mean. So you're going to have to do 60 plus 65 plus 65 plus 70 plus 70, right? And then plus 75 plus 75 plus 80 plus 80 plus 85 plus 85 plus 90 plus 95 plus 100. And divide by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And then you're going to divide that by 15 to get your mean. Same thing here. You're going to do 60 plus 65 plus 70 plus 75 plus 75 plus 80 plus 80 plus 80 plus 85. Sorry, 85 plus 85. Add them up and then divide by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Again, divided by 15. And find the mean. And then you're going to tell me which one is bigger and by how much. So the answer to this, I'll just give you the answer because I'm not going to do it. Actually, I'm just going to leave it like this because that you can do by yourself. Number 11. Here's a dot plot. So this is how many canned foods each student in Class A and Class B collected. Based on the information, which statement is true? So let's see which one is true. Both the dot plots for Class A and Class B have centers of 23 cans. Number is this 11. Is the center 23? Or if you cross and cross, 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 right? Do you think the center? Cross, 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 cross. Will it be 23? I don't know. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Cross 1, cross 1, cross 1, cross 1. And what's the center? 23. What about here? Do you think the center is 23? I also think this is 23. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Cross, 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 cross. Cross 1, cross 1, cross 1, cross 1, cross 1. And look at the center. Isn't that, so that's true. The median is 23 for both of them. So A is the one. And that's the one we want. We don't even have. So Class B says the most common number for Class B is 25. Is that true? No, the most common number was 26. So that's not true. The dot plot for Class A has a larger spread than Class B. Is this? This goes from 20 to 26. This goes from 20 to 26. It's not bigger. It's the same. Okay, so we can even stop there and we know that their answer is A. 12. Two box plots shown below, the spread of the data. So which statement correctly describes the spread of the data distributions for box A? Which one is true? The spread of the data distribution for class B is 5. Okay, actually, I want you to skip 12. I don't want you to do 12. All right, so I'm going to skip 12. 14. The box plot below shows the number of hours Anne and Nathan worked at the bakery. So this is how many hours they worked in the last 2 weeks. Which of the following statement is true? Okay, if you look at the box plot. Both of the box plots are symmetric. Well, let's take a look at that. So 14, right, this is the middle, right? Do you think this side over here looks like this side over here? No. So already, because this is saying that Anne and Nathan, so again, if you look at, you think this side looks like this side? No. So A is gone because they're not both symmetric. The interquartile range of the number of hours Nathan worked is bigger than the interquartile range of the number of hours Anne works. And remember, the interquartile range is Q3 minus Q1. Do you think if I did Q3 minus Q1 over here, it's going to be bigger than this Q3 minus Q1? So which one is bigger, this one or this one? So this one is going to be the bigger IQR, right? So that's also true. But we 14. Oh, so is this, so Nathan is not bigger. The IQR of Nathan is not bigger than the IQR of Anne. So that's gone. The mean number of hours. Okay, this one, anytime you hear that, how can I find the mean? To find the mean, I have to add all the numbers and divide by a number. Can you add all the numbers? No, we don't see all the numbers because I don't know what numbers are in here. But this one, you don't even have to consider. So the median numbers of hours Nathan work is half of an hour greater than the median number of hours. So Nathan, here's the median. Is this bigger than Anne's median? Yeah, it's bigger. And by how much? Remember, this is half, right? 1, 1.5, 2. How much bigger is this median than this median? It's about half more. So the answer is D. 15. Two box plots are shown below. Based on the data in the box plot, which statement is not true? So we're looking for the false one. Which one's a lie? The interquartile range for box A is greater than the interquartile range for box B. So the interquartile range is Q3 minus Q1, and then Q3 minus Q1. Which one is bigger, box A or box B? So this one is true, right? So we don't want that. We're looking for the one that's false. So that one's true. The spread of data box A is greater than the spread of data box B. Do you think the spread is bigger? So look at this spread. For data box A, it's from here all the way here. And for data box B, it's from here to here. Which one's bigger? Box A. That's also true. D, C, the median of the box of the data, the median of the data in box A, this median, is smaller than the median in box B. Is that true? Yes, this one, the median here, is smaller than the median here. So this is true, that's true, this is true, so they're all true. So there's no, everything is true. There is no false. So that's your answer. 16. Here is two classes and there are how many hours they study for a test. Which statement is supported by the dot plots? Class A has more students who spend 2, 3, or 4 hours studying their final than Class B who spent 4, 5, 6. So Class A, let's look at 2, 3, 4. 2, 3, 4. And let's look at Class B, 4, 5, 6. So we want to know, is that true? There's more people in here. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There's 15 people here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And there's 14 here. Is Class A bigger? Yes. There's more people here than here. So that's true. So Class A has a center of 3. Yeah. Class B has a center of 5. Oh, I don't know if that's true. So let's see. 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. So you're going to have 4. This is 4.5. So class A, one second, and I'm going to pause. Yes. Okay, so where are we? So again, class A has a center of 3 and the class B has a center of 5. So that's not true. Class A has more than half of their students who spent 4 more hours studying. And class B, is this 4 more? Is this half of the people? Is it more than half of the people? How many people are here? 1, 2, 3, 4, 5, 6, 7, 8. Do you think that's, and how many in total? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's 20 people in total. How many people are here? More than half? How many people are here? More than half? No, that's not true. Class A has a larger spread than Class B. Class A, the spread is from 1 to 6, right? And Class B has a spread from 1 to 6. They're the same. The only one that's true is A. 17, Ricardo surveyed a group of 7th graders and a group of 8th graders to determine how many movies they have seen this year. Which statement is true based on the plot? So 17. The data for groups of 7th graders has a center of 7. So this does it have a group of 7? And the data for the group of 8th graders has a center of 6. Oh my God. Does this have a center of 7? I don't know. Let's see. Well, the center. So we're going to cross one from each side, right? 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. And you know what? The center is 7. So, and the center for the 8th grade is it 6? Well, let's see. 1, 2, 3, 4, 5, 6, 7. 3, 4, 5, 6, 7. 1, 2, 3. 1, 2, 3. 1, 2, 1, 2. And yeah, guess what? The center is 6. So this is true, right? The median here is 6 and the median here is 7. So that's true. And the rest, I don't even have to look at it. But yeah, I'm not even going to look at it. 18, because I want the one that's true, right? So 18, this should have an 18. Box plots show the number of books that read by a group of 7th graders and the number of books read by a group of 8th graders over 6 weeks. So 8th graders, 7th graders. So the number is this 18. Let's see which one is true. The lower quartiles for both data distributions are equal. So the lower quartile is this one, Q1, and this is Q1. That's also called the lower quartile. Are they the same? No, so that's garbage. The upper quartile, which is Q3, here's Q3, and this is Q3. The upper quartile for the 8th graders is 1 1/3 times the upper quartile for the 7th grade. Yuck. Can we really? Let's go back to C. The spread of the distribution for 8th graders is equal to the spread of the distribution for the 7th graders. So we know A is out. So is this the spread from here all the way to here, and the spread from here to here? Is it the same? Do you think they're the same? No, they're not. Obviously, this one's much bigger, right? So it's saying that they're the same, so that's not true. The interquartile range for the 7th grade is 1.5 times the interquartile range for the 8th grade. Oh my God, why the? Right, so let's see. Well, I'm going to have to find the Q interquartile range. So the upper quartile, what's the upper quartile here? 8. This is 3. What's this? 6, and that's 2. So the upper quartile for the 8th grade is 1 1/3 times the upper quartile of the distribution of the 7th grade. What the heck? What? How's that 1 1/3? Let's see the interquartile. So this is Q3 minus Q1, which is 6 minus 2, which is 4. and this one is Q3, which is 8, minus 3, which is 5. So it's saying that the interquartile range for the 7th graders is 1.5 times the interquartile range. No, the interquartile range of the 7th graders is not 1.5 times. It's much smaller. So that one is also gone. So just by default, because this one's wrong, this one's wrong, this one's wrong, our answer is this. But I'm not too sure why they say the upper quartile, which is 8, of the 8th grader is 1 1/3 times the upper quartile of the 7th grade. So I'm not sure, but that's it. Well, this is it. So hopefully you will study it, and let's see how you do tomorrow.